Hey there, School of Tomorrow students. I'm just doing a little context setting up, giving a sense of where we are on the timeline, what's recently been added, what's recently changed. If you haven't been to Isotope Decay in a while, just added this poster. Today I'm going to talk about Python, is what I'm going to talk about. So we're going to be in Spider most of this time. I've got what are called scope stories because I'd like to help you learn what we mean by scope, and then in any language that's going to come up. If you're just joining us from the 2 Dickinson Street crowd, shout out. You might just be sampling because I mentioned 2D, or I showed 2D in a recent picture. This is a Princeton University institution. I'll explain it in other videos. So let's get to Python. I hope you don't mind a little gentle fan noise in the background. This laptop is a MacBook Pro from around 2009. Now I bought it later than that. I maybe gave the impression that I got it recent, as long ago as that. But I used a Mac Air for some years, sent to me by the company I was working for, and then found this one in a Asian food market. So, talk about scope. Speaking of Asian food market, one of the posters we're going to look at is this one, explaining how we're proud that Python does not use curly brace convention to show scope. So what I mean by that is on the left here you see this function Vegas, and it has a stays in Vegas name internally to it. By internally I mean indented under. And in a curly brace language, we indicate scope, like what's part of a function. Well, we open the curly brace, give the parts of the function, and then close curly brace. That's how JavaScript works, C++, C#, Java. It's very common, right? But we don't do that in Python. We have what's called significant white space, which some people claim drives them crazy, but as you know, it helps organize your code and make it more readable as a requirement, not just as something cosmetic. So we're going to print Vegas, meaning print what it returns, right? We're going to create this callable object called Vegas. We're going to call it inside a print function and get back whatever string it returns. We know it's going to return some event, but the point here is there's no stays in Vegas variable that sticks around. It's created inside the function. You could say the function pitches its tent, creates this variable, and then returns and destroys all evidence that such a thing ever existed. Stays in Vegas, disappears without a trace. And I know that's going to happen, so I have the foresight to wrap it up in a try except statement here. I say, okay, print stays in Vegas, knowing full well there's nothing to print at this point. Despite its being assigned internal to Vegas, once Vegas is run and over, there's no lingering stays in Vegas. So we'll run this. I hit the green arrow. What I'm suggesting is you make these little stories yourself, right? Make test programs of this kind, this short, and this meaningless. You're studying the grammar, and therefore you're not looking for something super meaningful, really. So moving on, this is Mayor Blum, Mayor of Vegas, set at the global level on line 11, meaning this is internally available to functions. They can kind of like looking at the stars at night, see the globals from internally. However, we're also free to assign a Mayor of Vegas inside of Vegas, and really treat this as insulated and in a world unto itself as before. So we're going to print out, using a format stream, a question. Is this mayor elected, right? And then we're going to run that function. For the moment that function's running, we're going to have a mayor bleep mentioned, but by the time we get down to line 21 and we're back to printing the Mayor of Vegas, we're going to revert back to the global value Mayor Blum. Because really this global value floats aloof and untouched by the goings-on inside of Vegas below. The function is not able to change the global value on its own. It doesn't have that power. It can use the same variable name. That it does have that power, and we want it to have that power. We don't want people writing their functions to worry that they're stepping on the toes of globals that might already be defined, but nor do we want them to change the values of those globals inadvertently. If they don't know those globals exist, and how could they in some cases? You're just coming in and making a function. You want a clear sandbox where nothing in the sandbox is going to destroy what's going on around you unless you explicitly make the link. So I'm going to use reset to make sure all my values are empty. We're back to a pristine environment before I run this. And I'll tell you a couple more stories. So Mayor Bleep, is he elected? Actually, no. By the time we get out, we're not looking at Mayor Bleep anymore. So story 2, 3, and 4, let me explain. Here I'm using the actual global keyword. You can see it's in blue, highlighting keywords in blue. And here I'm making the coupling between the internal guts of the Vegas body, the Vegas function body, and the outer global. I want them to be linked, and therefore when I make Mayor Bleep the mirror and echo that in the print statement, that's going to have changed it at the global level, thanks to this use of the global keyword, which only makes sense inside of functions and so on. You don't use it at the global level itself. So here I'm expecting the mayor of Vegas to actually be Mayor Bleep at the end of the day. Let's check that out. Let's make sure we're not running into any other presets from the last time. It's kind of like erasing the blackboard between tests. Run it again, and there we do. Have Mayor Bleep. So that was story 2. Let's look at story 3. I'm not showing the use of non-local, another keyword, not in this video. I'm moving on to what we call a closure, though. And this is something in computer science you may run up again in some lecture or talk and you wonder what it means. In the Python context, I'm actually going to return a function, a callable object, from the guts of Vegas. Inside of Vegas, I'm going to define a function named mayor, and mayor's job is to return mayor of Vegas. Now, what's it going to bind to? Is it going to bind mayor of Vegas to the outer context inside the function, in which case we'll get Mayor Bleep as the return value, or is it going to bind to the global? So here we run the Vegas function on line 20 and get back this callable, this function called mayor, except we're going to rename it to get mayor, you could say. And then we're going to call it down below. Now when it was defined in this context of Mayor Bleep just outside the door, in the same context, in the same function. So the question is, does it bind to that? Even though the mayor of Vegas at the global level could stay Mayor Blum. Run that to find out. Do a reset first, and then one more story. Okay, here we go. Green arrow. This is a brand new upgrade, by the way. I did a whole bunch of upgrading recently to get these all working smoothly again. That's a responsibility you have when you're not being served by some company that's going to come around and update your workstation for you. Even if you are working for a company, it may be your job to keep your particular software platform spick and span, up to snuff. So sometimes you'll be doing that. Okay, so Mayor Bleep and Mayor Blum. Why? Because at the time get mayor was defined, Mayor Bleep was the immediate context and was used. That's what we call a closure. In other words, the content of the immediately surrounding Vegas function was basically consulted when the mayor was defined, the mayor function. It had something to use. It had Mayor Bleep to use. If I change this to Mayor Blob and run this again, we should see a similar use of blob here. Get the idea, right? Even now, after all this is run, I can run mayor, and I get back excuse me, I can't do that. I can get that function again, Vegas, and now I can run it, and I get mayor blob, right? And even if the mayor of Vegas at the global level is mayor blob, still this is what stuck with the function. So you're going to get this last story a little bit different now. It's not linking to anything in the surrounding Vegas function to get the mayor of Vegas. At this point, it has no choice. Mayor has no choice except to look at the mayor of Vegas at the global level. So the question is, when I run this, has there been any binding that's like permanent? In other words, did mayor of Vegas permanently become mayor Blum at this time? Or is it just going to return whatever is the global value when the mayor function is run? So I create it twice. I create it once when mayor Blum is the global value. Then I reset the global value to mayor bleep, and then I get the function a second time. I ask for give me back mayor please, and this time I'll call it mayor2, and then run them both one atop the other. What's that going to do for me? Run it. It's mayor bleep all the way down, which means it doesn't matter that I define it right after mayor Blum has been set as the global. It's when I run it, it's going to take whatever is global at that time. So I don't run it until later, and by the time I run it on line 26, we've already changed the global to mayor bleep. So everybody agrees, mayor bleep. All right, these are what we call scoping concerns or scoping rules, and any language you're going to learn likely has some rules like this for controlling where names are available to the interpreter. Which names, if there's multiple use of the same name, that doesn't have to be a showstopper. That doesn't have to result in major confusion, as long as you're clear about the rules of containership, like what contains what and what's the scope of a name. So this gives you some initial experience with that. Hope that was useful, and we'll see you back at School of Tomorrow.